examples because we're new at this, and then I want to go back to our graphs and say, oh, this graph is this, problem from substitution. All right, so I've got these two equations. Which one would be easiest to get one of the variables by itself? You want to choose very carefully because there is a correct answer. Which variable? The 3x, the negative 4y, the y, or the 2x do you think is easy to get by itself? That y right there, right? Because in one step, I can get y by itself. All I have to do is subtract the 25 to the other side. So I'm going to write down that I'm going to subtract 25, so I have y equals 2x minus 25, right? Because those are not like terms. All right, so my next step, right, is to circle that this stuff is going to get plugged in for the y in the other equation, right? So I'm just going to draw an arrow of where I'm going to plug it into. I'm going to plug it into that y in the other equation. Everyone see where we are? Page 106. It's not a resource. It's like numbered at the top. So let's rewrite that top equation now. I have 3x still, so 3x. And then I'm going to still write that minus 4. In place of the y, I'm going to write parentheses 2x minus 25. So I'm writing this. Right? So 3x minus 4y, and then equals negative 5, I still have to write. Equals negative 5. Now, you just did the hardest part of substitution. You've got a variable by itself, and you've written it out in the new equation. This should be the easier part when you're doing the algebra to get x by itself. Because this should be like an algebra 1 skill, solving for x. I know that we need more practice on it, but you've already done substitution. Now, if you're struggling with this stuff, you're not struggling with the algebra 2 substitution. You're struggling with the algebra 1, getting the variable by itself. So that might be what we need to get some help on next week. All right, so I'm going to distribute this negative 4 into the parenthesis. So let's rewrite it, 3x minus 8x, because I have negative 4 times 2. And now I have to do negative 4 times negative 25. And if you need a calculator, fine, but that's just a positive 100, right? If you have 4 quarters, you've got $1. So plus 100 equals negative 5. What would be my next step? Combining like terms. So I have a positive 3x and I have a negative 8x. So how many x's do I have? I'm at positive 3, but I go down 8. Negative 5. If you need a calculator to do the minus stuff, that's fine. I'd rather you, work on mental math separate from working on algebra, because if you don't know the exact number, it's going to mess up your problem. All right, so I have negative 5x plus 100 equals negative 5. We're on page 106. What's my next step to get x by itself? Subtract 100 to the other side. So I have negative 5x equals negative 105. Now you might need to do it on the calculator if you're not sure, because we need to take negative 5 and divide it to the other side. So I'm going to get a positive answer. I'm taking 105 and dividing by 5. What is it? Did you do that in your head? Do you know what 100 divided by 5 is? 100 divided by 5 is 20, right? 20 times 5 is 100. So there's one additional 5. So it's positive 21. Or chuck it on a calculator. This is number 2 on page 106. All right, you just got half of your answer. See, page 106, solving by substitution. We did number 1 yesterday, so we're on number 2. All right, what's your next step? Once you've solved for x, you've done a lot of work, but you only have half of the solution. But the second half of the solution is really easy to get. You go back up top where you circled what y was equal to, and you're going to plug in your x value, right? So all I have to do is plug in 21 up here. 2 times 21 minus 25 will give me my y value. So you're going to do on your calculator 2 times 21 minus 25. 2 times 21 minus 25. So y equals 17. And then once you have an x and you have a y, the best way to write your answer is as a coordinate. I don't really have a lot of room. 21 comma 17 is my final answer. There's a lot of algebra steps. So if it's hard to read your handwriting and you need to do this on a sheet of lined paper, separate, that's fine. And then just attach your work. I tried to go as step by step as I could. Some of you, you'll start to do a little bit more in your head. All right, so I still got an intersection point. The two lines intersected, and that was the answer. So something different is going to happen, I think. Make a liar out of me, but something different is going to happen on example 3. I'm just waiting a second so that we can all copy that one down first. All right, so example 3, why don't you look at it? Which variable is going to be the easiest to get by itself in example 3? There's actually 2 correct answers, but which one should we pick? Did you get it all? Wow, you're a fast writer. Okay. So which one you want to pick? There's the top one that has a y, and there's the bottom one that has a y. You could go either way. Let's just pick the top one so that we're all doing the same thing. So I'm going to add, so I'm going to take y minus 2x equals 7, and I'm going to add the 2x to the other side. So y is equal to 2x plus 7, right? So I'm working the top equation. Can you see this okay? I'm working the top equation. Now I know what y is, 2x plus 7. I want to put that into the other equation. And this time there's no coefficient of y, it's just y. So you don't have to worry about the parentheses and the distributive property because there's nothing to distribute, right? There's not even a minus sign to distribute. So I'm going to have negative 2x plus 2x plus 7 equals 10. What do you see that's going to happen that's a little bit like, uh-oh, what happens? The x's add up to 0, right? So I get this weird step. 7 is equal to 10. Is that a true or a false statement? Does 7 equal 10? No. So this problem has no solution because I can never get the two lines equal to each other. What kind of lines must they have been? Yeah. Can you see that kind of up here? Y equals 2x plus 7. What would this one be? This one would have been y equals 2x plus 10. So they would have been parallel lines with different y-intercepts. Can they ever equal the same thing? No, so that's why there's no solution. That's why 7 will never equal 10. Maybe you want to put a big slash through it. 7 can never equal 10, so there's no solution. You might get 0 equals 15 or 2 equals 30. There's no variable, but the two numbers are not equal to each other. So that is a case when there's parallel lines. All right, so let's look at one more where they kind of come out as a weird solution here. Which y is or x is easy to get by itself? I would probably go for this top equation maybe because there's just a y, even though it's a negative y. So let's work the top equation. 10x minus y equals 100. What would be the first step to get y by itself? Subtract the 10x to the other side. So negative y equals negative 10x plus 100. Y is not quite by itself. What do I have to do to get y by itself? When you divide by -1, what are you actually doing? You're really just switching the sign on every single number in the problem. If you want to go through and say that you're dividing by -1 to show that step, all I do is I just switch all the signs. So this would be a positive y, this would be a positive 10x, and this is now a negative 100. So we're going to take that and plug it into the other equation. I'm just going to draw an arrow. We're going to plug it into that. We worked the top equation. We're going to plug it into the bottom equation for y. You don't want to plug it back into the top equation. You have to plug it into the other equation. All right, let's see if we can write that out. So I've got a 2. So I'm going to have a 2, then a parentheses, 10x minus 100. So that's my 2y from the bottom equation. And now I'm just going to copy the rest of the bottom equation. So I've got a minus 20x equals negative 200. And now I have to work that equation out for x. What's my first step to start simplifying this? Distributive property, right? And then combine like terms. So distributive property, you'll start getting good at this because it's the same process every time. So hopefully the algebra steps will sink in. In algebra 1, you just solved equations for the sake of solving equations. Now you're at least using your algebra skills to solve a more complex problem, the intersection point. Does that sound like a young child? Okay. All right, so I got 20x minus 200 minus another 20x equals minus 200. So what's happening on this problem? Everything cancels out. Well, the x and the x cancel out, right? Because you have a positive 20 and a negative 20. But you get negative 200 on one side and you get negative 200 on the other side, and I have no x's to solve for. But do I have a true statement? Over here I said no solution because 7 couldn't equal 10. Does negative 200 always equal negative 200? So this is that other situation where it actually is the same line on top of itself. So it's any point on the line. Many solutions. Every single point on the line is a good one. So before we practice a couple, I just wanted to take us back to the resource page on graphing systems. So it's way back and it looks like this one. It was a resource page called Outcomes to Systems Graphically and Algebraically. So it's like way back kind of at the beginning of your packet. It's not numbered. I wrote down, what does this look like when we solve algebraically? So that's like when we do substitution. We could do substitution on this same exact problem. I'm not going to do this problem out. I'm just going to say substitution and you find x equals and y equals, right? Because I don't want to do that whole example, but I want to talk about what happens when you do substitution and it's no solution. So you could just go to a substitution example in your, resources and find it. What would no solution look like when I'm solving it? And what does many solutions look like when I'm solving it? So you get a false statement. For example, we got 7 can never equal 10. So it's no solution. So you can be on the lookout for getting a false statement. Oh yeah, that means the lines are parallel and there was no solution. And the other thing that could happen is you get a true statement. What did we get? Was it negative 200 equals negative 200? Negative 200 equals negative 200 was all points on the line. Is that enough to like trigger back, if you're doing a test, like, oh, I got this outcome, what does that mean? And if it's not, these are your notes. So you could add an entire example onto this resource page later, or you could do this problem out if you wanted to later. But this is just some quick notes, like what's going to happen when you're solving? Oh, You're going to get a true statement or a false statement, or you're going to get X and Y. So just wanted to put that on the resource page in case you need to look back at that. Does everyone have that on there? All right, so I'm going to have you try one example on your own, and I'm going to walk around and help you. And then I want to plant the seed for next week of like doing this with an application problem. So we're not going to get through all of these questions today on the back. These are just more practice with graphing. That would be a great warm-up for Monday. But if you go down here to example, I'm going to pick example 4 actually. On the next page of page 106, could you guys try to work question 4 and see if you could get it by substitution or elimination? Because this is an example that's going to have an intersection point. So you're looking for like X to be 10 and Y to be 8 or whatever it is. So it's not going to be a special one with no solution. See if you could work number 4, doing substitution, and actually get an answer. Restroom? Oh, sure. You're welcome. Like on a test. All right, so this is the back of 106, number 4. Did you notice it was already set up for you? So I can take my, this, is it focused? 4x plus 1 and plug it into the bottom equation right there. So I have 2x plus, I don't have to write parentheses because there's not any coefficient, just 4x plus 1 equals 37. So mental math here, I'm combining these like terms, so I get 6x plus 1 equals 37. And a lot of you got all the way through this problem. You subtracted 1 to the other side, so 6x has to be 36. And you divided by 6 nicely to get 6. If you stopped there, you didn't do the second half of the problem, right? You have to get x and y to get the full solution for the intersection point. I like circling what I'm substituting in because then I can quickly see I'm going to put this 6 into my circle up here, and that's going to give me what y is, right? So when I plug it in, 4 times 6 is 24 plus 1 is 25. So y must be 25. And then I write 625 as my final answer. And so one of the reasons I like math is always checkable. So I can check before I turn in my quiz a lot of times that I have the right answer. So for this problem, you could literally take your 6 and your 25 and you could plug it into the other equation and it should work. We already know that it works in the top equation. Does it work in the bottom equation? So let's see, 2 times 6 would be 12, and then plus 25, yeah, 12 plus 25 does give me 37. If you made a mistake, it won't work when you plug it into the other equation, so you could go back and look for your mistake before you turn in your quiz. So substitution is always checkable, just plug it back in. So we'll do this page kind of as a warm-up on Monday. I think that would be a good warm-up.